I got dividing polynomials. So we have a couple different ways we get to divide polynomials. If we are dividing by a binomial or larger, we have three different ways we can do it. If we are dividing by just a monomial, which is one term, that's different. So let's talk about that first, just so you know for the future what that means. So we're going to start by saying when dividing by a monomial. You want to divide each term by that monomial. So for example, if I say I have, 6x to the fourth plus 4x to the third minus 2x squared plus 7x minus 1, that's a polynomial, and I want to divide by 3x squared. What we're going to do is put that 3x squared underneath every single term and simplify them. So I'm going to actually have 6x to the fourth over 3x squared plus 4x to the third over 3x squared minus 2x squared over 3x squared plus 7x over 3x squared minus 1 over 3x squared. If we set it up that way, starting with the first term, we're going to reduce. Do our numbers 6 and 3 reduce? They do to 2. And where are there more x's? On the top, right? So x squared can go into x to the fourth, x squared times. That first term reduces to 2x squared. Second one, can I reduce 4/3? So I'm going to write 4/3 here. Where do I have more x's, on the top or the bottom? So how many more do I have? Just one. So that x squared goes into x to the third, and I just have x left over. Minus, can 2 over 3 reduce? It cannot, so I'm going to write 2 over 3. What about my x's? They totally cancel, don't they? Plus, let's go to the next one. 7/3 does not reduce. In this one, where do I have more x's? I'm going to put my x on the bottom. And then minus 1 over 3x squared, because nothing cancels there. This would be your polynomial if you divided by a monomial. Okay? It is. It is. They're going to be big. So, but I really want to talk about dividing by binomials. All right, because this is simply reducing fractions, and we've done that before. So what I want to talk about is when we divide by a monomial or a binomial or larger. We have three different types or different ways to do it. One is long division. That's what we are going to do today. Second way to do it is with the box method. And the third way is what we call synthetic. Now, long division works every single problem. Long division always works. Doesn't matter what the problem is, it always works. The box method works 90% of the time, but if you have some missing terms, it doesn't. Synthetic only works if you have a binomial you're dividing by. It's the easiest and fastest, but it only works if you're dividing by a binomial. Okay? So, we're going to start with long division today. Now, everybody remembers dividing using long division, right? We haven't done it in years, but, so let's just do a long division problem to begin with. All right? Let's say I have, 2,467, and we're dividing by 5. right? What did we typically say when we were kids? How many times does 5 go into 24? Goes in 4 times, right? And we put the 4 right above where the 24 finishes. Yes, 4 times 5 is 20. And then we subtracted these. Then you bring down the 6. Very good. How many times does 5 go into 46? Does. Goes in 9 times. 9 times 5 is 45. We drew our line and we subtracted, right? 46 minus 45 was 1. We brought down the 7. Good. 3 times 15. 3 times 5 is 15. So, one way to continue would be to add your decimal and add a 0 and keep going. What else did we do with that 2? What else did we call it? There's other ways to write it. Instead of having to put your decimal and keep going, sometimes we take that 2 and write it over the 5 and make a fraction, but there's one other way you did it. In the beginning of time, what was the very first thing you did? We called it a remainder of 2. Do you remember that? You don't remember long division from grade school? I know. All right. So the whole idea today, we're going to do this exact same thing, just with polynomials. Okay? All right. It'll be all right. So when we do it, I'm going to say it a certain way every time that works all the time, okay? So when I say it, we're going to kind of follow along, and you're going to say it in your mind eventually. I'm hoping. I'm hoping. So let's start off with, an easy one. So here we go with example number 1. All right. So let's say I have 6x squared plus 7x plus 2. And I'm going to divide by 2x plus 1. All right. So when you say that, or how we're going to say it today, is what times 2x is going to give me 6x squared? 3. Okay. 3x. Yes. Thank you. So above where the x's are, I'm going to put 3x. Okay. Just like we put our number up there, I'm going to put the 3x up there. Now I got to multiply. 3x times 2x is 6x squared. And 3x times 1 is 3x. So then we drew our line, and now we subtracted. But what I'm going to say to you is change your signs, because that means you're subtracting. So change and change. Excuse me. So now when we add them together, what happens to our x squareds? They cancel out. Those are gone. I have 7x and I have a negative 3x, gives me 4x. And just like we did when we did long division, we're going to bring down plus 2. Now what times 2x will give us 4x? Just 2. So plus 2. And then we multiply. 2 times 2x is 4x. And 2 times 1 is 2. We're going to draw our line, and then we're going to change our signs. And we get 0. So in this case, there is no remainder. Okay? No, this is our answer. There is no remainder, though. All right? So one of the things you can say is the factor 2x plus 1 is a factor of that polynomial we divided because there's no remainder. Right? Kind of like when we divide in real numbers instead of polynomials, if it goes in evenly, it's a factor of it, right? Same thing here. Okay, shall we try another one? Okay. Here is example number 2. Let's go with 4x squared plus 23x minus 16. And I want to divide by x plus 5. All right, so the first thing you're going to say to yourself, what times x is going to give me 4x squared? 4x. I'm going to put that right here. 4x times x is 4x squared. 4x times 5 is 20x. Draw your line, change your signs. Yes, 3x, bring down minus 16. So then what times x is going to give us 3x? Good, so plus 3 up here. 3 times x is 3x. 3 times 5 is 15. Draw your line, change your signs. Your 3x's drop out. I have negative 16 and negative 15 is negative 31. That is going to be our remainder. You're going to write it top, put a capital R, negative 31. How are we doing? We're getting there? Give me questions, something, anything. No questions? Seems okay so far? For now. All right, let's try one a little harder. Example number 3. So let's go with, I want to make sure I write it like you have it in your homework. Let's go with something that looks like this. Let's say I have x squared minus 3x minus 40, and I want you to divide by x plus 5. So which one of those polynomials are going to go in the house, so to speak?
The x squared minus 3x minus 40.
Good. Yeah, so in the house is going to be this one. Yep. And x plus 5. David, did you have a question? Okay. All right, so now, what's the first thing we ask ourselves? What times x equals x squared? So it's just x. So put that above our x's. X times x is x squared. X times 5 is 5x. Draw your line, change your signs. So our x's cancel out. We have negative 3x and negative 5x is negative 8x. Bring down minus 40. So what times x is going to give us negative 8x? Yes, very good, Jarrett. Negative 8. So negative 8 times 5 is negative 8x. Or sorry, negative 8 times x is negative 8x. And negative 8 times 5 is negative 40. Again, draw your lines, change your signs, and everything cancels out. There's no remainder. Okay? So this would be a factor of it. All right. Let's go with example number 4. 2 more and I'm done. Example number 4. So, problems at the top. Right now I have you doing 9 through 18. All. I might change that yet. I don't know. So, technically this covers 9 through 16 as you look back at your notes. As you look back at your notes, this is how all of them in the first section are set up. So, if I have, let's say, x to the third minus 13x minus 12, and I want to divide by x minus 4. So I want you to notice what is special about this first polynomial I wrote down. What's missing? Yes. This one's to the third, yep, so it's special that way. And then what term is missing? Because you really should have a third, then a what? Then a squared, and we don't have one. So when we write it down, we have to write it down as 0x squared. We have to put in what we call a placeholder, okay? So inside my house, I'm going to have x to the third plus 0x squared minus 13x minus 12. On the outside, we're going to put our x minus 4. All right. Starting at the beginning, what times x is going to give us x to the third? X squared. 2x will give us 2x squared, right? So we want x squared. X squared times x is x to the third. X squared times negative 4 is negative 4x squared. Draw your line, change your signs. Super important step. Now, every time that first term, right, should drop out. If we multiplied correctly, these should drop out. Now I have 0x squared and 4x squared, so I have 4x squared. Bring down minus 13x. So what times x will give us 4x squared? 4x. Very good. 4x. So 4x times x is 4x squared. These should match if you're multiplying by the right thing. Then 4x times negative 4 is negative 16x. Draw your line, change your signs. So again, your 4x squareds are going to cancel out. I have negative 13x and positive 16x is 3x. Bring down minus 12. So then what times x is going to give me 3x? Good. So plus 3. 3 times x is 3x. 3 times negative 4 is negative 12. Draw your line, change your signs. And no remainder. All right, Jarrett.
So when there's the 0x squared and 4x squared, how does the x's not cancel out right there?
Well, because really it's only a placeholder, so technically it's saying we don't have any to add to this, so we still have this to go. Okay? That's a really good question. Anybody else? We're doing all right? One more example? That way if you have to finish the worksheet from yesterday or you can get started on this homework. All right? Okay. So number 5. Number 5. Example 5. This is going to cover for today 17 and 18. And the directions say determine if the binomial is a factor of, let's go with 3x to the third plus 9x squared plus 8x plus 4, and I want to know if I divide by the binomial of x plus 2, whether it's a factor. How will I know if it's a factor? If it goes in, it's going to be a factor if there's no remainder, right? So when we divide it, in this one, when we divide it, that just means that there's no remainder. Okay? All right, so we're going to divide and see if it's a factor. So inside the house, I have 3x to the third plus 9x squared plus 8x plus 4. On the outside, we're going to put x plus 2. What times x will give us 3x to the third? Good. Excellent, you guys. All right, 3x squared times x is 3x to the third. 3x squared times 2 is 6x squared. Draw your line, change your signs. So now our 3x to the thirds cancel out. I have 9x squared and negative 6x squared, so I have 3x squared. Bring down positive 8x. All right. What times x will give me 3x squared? 3x. Very good. Positive 3x. 3x times x is 3x squared. 3x times 2 is 6x. Again, draw your line, change your signs. 3x squared cancel out. I have 8x and I have negative 6x. So I have 2x. And I'm going to bring down plus 4. Good. What times x will give us 2x? Plus 2. 2 times x is 2x. And 2 times 2 is 4. Draw your line, change your signs. Do we have a remainder?
No.
So this is, yes, it's a factor. All right, how are we? How are we doing? This is not bad? Good. Good, good, good. All right, so here's the deal. Let's go with how about 9 through 19 odd. So I'll change it a little bit. Instead of 9 through 18 odd, let's go 9 through 19 odd. You guys okay with that?